Good morning, or good afternoon, depending which class you're in. Welcome to the last class before break happens. We have a number of things that are happening for today, including a PhET simulation, which will take you a little bit of time, a little bit of reading, a few problems. Before we do that, just want to review with you about the coping calendar. Lots of good stuff in there for you to do every single day for the next 30 days and beyond. Here's something you might be thinking about, learn something new or do something creative. However, I really like this one. Rediscover your favorite music that really lifts your spirits. Maybe you'll be doing that during this time. Listen to a little music while you're doing some of your work. I tend to do that. In any case, let's get into what's happening for today. You should have already completed the PhET lab and hopefully turned that in. Maybe you're going back to that a few times, which is just fine. There's a number of things that are happening with that, including at the very end they're asking you to formulate your own sort of test or experiment, which may take a little bit of time. In any case, there's a number of things that's happening to help you understand more about what's called the combined gas law and the 4 variables that we measure to understand about gas. So make sure you go through that, those steps, and it's designed so they are to be done in order. So I really recommend that. If you have any questions, I'll be available on either through Shobi, or you can go and email me, or you can contact me through Zoom. Good luck with this today, and I will see you in just over a week. So some observations that you may have made about this part of the sim bucket. There are 3 different types of atoms. These are all noble gases. So they are increasing in size. You'll also notice that as they move, the bigger ones are moving at a different rate than what the smaller ones. The bigger ones move slower and the smaller ones move faster. You should also notice that they all travel in a straight line. So as I kind of go back and forth, they'll go in a straight line until they hit something. And when they do actually hit something, the energy between them is conserved. So something's moving fast and something else is moving slow. When they hit each other, they exchange that energy and sort of change places that way. You should also see that there's lots and lots of spaces in between these. There's not attractive forces to keep them together. And as you change the temperature, right now it's at a low temperature, so you can see that they are moving slow, if I could get this going. And let's put this up here. And they're moving faster when the temperature is higher. And the last piece is they're not always traveling at the same speed. Even within a particular type, they're not always having the same speed. So all those descriptions about those particles and observations really is about the kinetic molecular theory. So this is one way of stating the 5 different postulates. At the end of the video that you saw, they showed it as a pictorial, and there's a little bit different versions, but all basically are saying the same things. And these are the 5 main ideas that they use to describe, again, what's called the kinetic molecular theory. We're going to be focusing a bit on postulate number 3 here, and that's the one that deals with particles and pressure. And we're going to be looking, one of your readings has to do with how to change pressure on things. And the way we do that is through 3 other different parameters or things that we can measure, namely, and that we can change. Namely, it's temperature, volume, which means the size of something, and then moles, which is really how many of something that you have. So I think this is a good time to pause And why don't you go to the Actively Learn and take a look at the reading on factors affecting gas pressure, since we were just talking about that. And I'll wait for you right here while you go do that. It should take you maybe about 8 to 10 minutes. Okay, go on. Go on. What are you waiting for? But don't forget to come back. Well, welcome back. The reading talked about three different things that affect the pressure of a gas. That includes temperature, volume, and moles. So I want to relate those to 3 and actually 4 different laws, gas laws, and then we're going to combine those gas laws and use them in a couple different scenarios. So the first one is Boyle's law, and if you look at the top, it involves pressure and volume. If we take away this part that I'm canceling out and put in a K, the K means that it's a constant. So you can use this equation anytime you're changing volume or you're changing pressure. When you did your ChemThink, there was a graph of this, and it would have looked something like that, with pressure on the bottom increasing and volume here. So as the volume decreases, the pressure increases. So this is what we call an inverse relationship. The next one briefly of Avogadro's law, which involves volume and number of moles. And from the picture you can see as you increase the number of bunnies there, the size of the bunnies gets bigger. So this is what we call a direct relationship. And if you were to do a graph of this, it looks something like that, where moles would be on the bottom. We use N to represent that, and volume will be at the, on the side. So one goes up, then the other goes up. The last parameter is about temperature and how temperature affects pressure. If you can see on the left-hand side, they're showing that the temperature is low, but as you increase the temperature, you'll notice that gauge, which is the pressure gauge, is going up, and so it's increasing the pressure. So P over T is equal to our constant, or we can also say P1 over T1 is equal to P2 over T2. This also is a direct relationship. So if you were to graph this out, it would look something like this, where increasing the temperature increases the pressure. There's a fourth gas law called Charles' law, which involves volume and temperature. And this too is a direct relationship. So as you increase the temperature, you can see everyone's huddled together there. The volume will increase. They get further spread apart. So this is a direct relationship as well. So this is the fourth of the gas laws. So what we want to do now is we want to, instead of looking at each of these as individual laws, we want to be able to combine all these things into one large law. And we call that the combined gas law. So combining them all results in what we call the combined gas law. And this is what I'm really going to ask you guys to focus on. The pressure times volume over the temperature times the number of moles. And that's equal to a constant. So we're going to try to use that to solve a few problems. We're also going to, from our problem set. Before we do that, let's make certain that you know what the common units are of each of these. And then I'm also going to introduce to you one word that I'd like you to think about when you think about that particular parameter. So this chart here shows us the 4 different parameters or 4 different variables that we can measure to understand about a gas. Some of the problems that we're going to be doing involve sometimes just 2 of those variables, sometimes 3, and can be up to 4. And we're going to use what's called the combined gas law. So I'll show you in a different video how we solve some of those problems. But you'll notice that I have written down what the units are. I don't have the abbreviation, so I'll show those to you at a little bit of different time.